Hello explorers and welcome to another video. Today it's day 3 of Advent of Code and let's just jump into it. So here we have day 3. The submarine are making odd creaking noises. So you ask it to produce a diagnostic report just in case. So this is binary diagnostic. The diagnostic report, your puzzle input, consists of a list of binary number which, when decoded properly, can tell you many useful things about the conditions of the submarine. The first parameter to check is the power consumption. You need to use the binary numbers in a diagnostic report to generate two new binary numbers called gamma rate and epsilon rate. The power consumption can then be found by multiplying the gamma rate by the epsilon rate. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers of the diagnostic report. For example, given the following diagnostic report. So we have a bunch of numbers here. Consider only the first bit of each number. There are 5 bits and 7. There are 5 0 bits and 7 1 bits. Since most common bit is 1, the first bit of the gamma rate is 1. Since the most common bit is 1, the first bit of the gamma rate is 1. The most common second bit of the numbers in the diagnostic report is 0, so the second bit of gamma rate is 0. The most common third and fourth and fifth bits are 1, 1, 0, respectively, and so the final 3 digits of the gamma rates are 1, 1, 0. So the gamma rate is the binary number 1, 0, 1, 1, 0, or 22 in decimal. The epsilon rate is calculated in a similar way. Rather than using the most common bit, the least common bit from each position is used. So the epsilon rate is 0, 1, 0, 0, 1 or 9 in decimal. Multiplying the gamma rate 22 by the epsilon rate 9 produces the power consumption of 198. The binary numbers in the diagnostic report to calculate the gamma rate and epsilon rate, then multiply them together. What is the power consumption of the submarine? Be sure to represent your answers in decimal, not binary. Okay, so there are 5 0 bits, 7 1 bits. Okay, so they are talking about the first column, considering only the first bit of each number, yeah. So they are talking about the first bit, the second bit, and so on. And they are talking about the most common and the least common of each of these. So I guess that the most common will always be the opposite of the least common. So if we have one value that is, for instance, 0, 0, 1, 0, 0, then the opposite of that would be 1, 1, 0, 1, 1. So that's one thing that we can take from this. So let's put in our data here. So we have string data like that, and put in a bunch of numbers. So now we can split this data up. So we're using the same technique that we did earlier, where we had the data up here and then a split down here. So now I want to split each line into different things as well. So I wonder if we are in a position now that an array would make sense, or if we still should use strings. I think we can continue to use strings. Let's do an integer array of positive bits, a new integer, and let's say that this array I will want to see in the inputs. So here we have 8, we have 12 bits in this little thing. So let's start with 5 and then do 12 after that. So we have to change it. So here we have negative bits. So the positive bits are 1s and the negative bits are 0. And here we have the count for each of those. So we take the line, we split it by nothing. That will give us some line array, I can say, like that. And then we will go for the line array, go through each of the columns, and if this string is equal to 1, then the positive bit count would be of this. We would increase that, else we would increase the negative bit count. And I, in this case, is the number of increment in this X position. So down here, we need to figure out which numbers are the largest. So for int I in the, you can say, positive count length I plus plus. So string most, let's do that, and then string least. Yeah, I think it's spelled like that. So now we can go through each of these and check if the positive count is larger than the negative count, then we say that most will have a 1 bit, add to that, and least will have a 0 bit. Else we will do the opposite. Zero, 1. So now we will want to do the big integer, int, we can call it number, most number, big integer, a new big integer, and then give it a binary, most. I wonder if we need to give it a radix as well. I think we will want to do that. And then we have the least number. And then we will print the most number, int value times least number, int value. So I think this could be our little function. So let's see here. Do we get something similar to their result? 198, which seems to be the correct value. So we might have just done it, which is interesting. So what I did here is I put in the data. I created two arrays which I would keep the count of the positive and negative bits, ones or zeros. And then I went through each line, checked each column. If I have a positive number, I will increase the positive count, else I will increase the negative count. And down here, I will check if the positive count is larger than the negative count. Then I will put this column into the most segment. Otherwise, it will be in the least segment. And I will give it this positive value. And using a big integer with a radius of 2 is the way to take a string value that is binary over to an integer value, which is a pretty nice feature. So that was this. And now I only need to change these values to 12 and bring in the real data. Like that. And hopefully we will get a good value down here. We got the value 4,006,064. So let's see if that's the correct value. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So let's look at part 2. Next, you should verify the life support rating, which is determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Both the oxygen generator rating and the CO2 scrubber rating are values that can be found in the diagnostic report. Finding them is the tricky part. Both values are located using a similar process that involves filtering out values until only one remains. Before searching for either rating value, start with a full list of binary numbers for your diagnostic report and consider just the first bit of those numbers. Then keep only numbers selected by the bit criteria for the type of rating value for which you are searching. Discard numbers which do not match the bit criteria. If you only have one number left, stop. This is the rating value for which you are searching. Otherwise, repeat the process considering next bit to be the right. The bit criteria depends on which type of rating value you want to find. To find oxygen generator rating, determine the most common value, 0 or 1, in the current bit position, and keep only numbers with that bit in that position. Okay? If 0 and 1 are equally common, keep values with 1 in the positive being considered. Okay. To find the oxygen generating, keep the most common value, 0 or 1, in the current bit position and keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with 1 in the position being considered. Okay? To find the CO2 scrubber rating, determine the least common value, 1 or 0, in the current bit position and keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with 0 in the position being considered. Okay? For example, to determine the oxygen generating rating value using the same example diagnostic report from above. Start with 12 numbers and consider only the first bit of each number. Start with all 12 numbers. Consider only the first bit of each number. There are 1 bits 7, then there are more 1 bits 7 than 0 bits 5. So keep only the 7 numbers with a 1 in the first position. Okay? Then consider the second bit of the remaining number. There are more 0 bits, 4, than 1 bits, 3. So keep only the 4 numbers with a 0 in the second position. Okay? In the third position, 3 of the 4 numbers have 1. So keep those 3. Okay? The fourth position, 2 of the 3 numbers have 1. So keep those 2. In the fifth position, there are equal number of 0 bits and 1 bits, 1 each. So to find the oxygen rating, keep numbers with 1 in that position. There are only 1 number left. Stop, the oxygen rating number is. Okay. So for one of them, we will keep the value 1 if we need to do any changing up, and that's when we are looking for the most common. And when we are looking for the least common, we will keep the one with a 0 if they are equal in number. Okay. So this is going to be interesting. I think we will need to change our approach a bit. So we do the same with the scrubbing down here. And finally find the life supporting number, multiply the oxygen generating and the CO scrubbing. Then we get that value. So we can at least verify that we are right. And I would say that I want to do to copy this into a new day 3B, because I want to keep the old thing here, because I think we need to throw pretty much everything away that we did earlier, because now we want to keep an array of data instead. Let's do a list, string, and call it new data, array list, like that. And we can start with our normal data. We still want to do this kind of split thing. And we still want to have the last part here, but only one of them. So let's see here. First off, I want to do a different thing here. I want to put all the lines into this new data. Then we want to go in here and split. Yeah, just go through each of these as a line, like that. And then I want to do a while loop, while new data size is larger than 1. We want to continue. Hopefully we'll not end up in a position where we are not able to do this, but let's not be nihilistic about it. So let's see here. We have this array like that, and string s is equal to line array, and then I, so we should get the value there. And here we can say int positive and negative, like that. And we just add to the positive or the negative. Like that. And if positive equals negative, we need to push these out because they will be in this thing here. So if they are equal, then we will keep every else if the positive are larger than the negative, we will keep some, else we will do something else. So this is going to be a lot of loops, so here we need to have string list, string keep list, new array list. So this is the values I want to keep down here. And if they are equal, we want to keep every value that is positive in this case. Perhaps we want to make a function now. Let's do that. So a public static string get value. And then a list of string data, or something like that. So let's do that. Return keep list, or the new data. Let's see here, we have the new data up here. We will return the first value there. For hopefully we will get only one value. So return the first one there. And I will take a little break. And we are back. And it's important to take a little break when the coffee is done. So let's just pour some coffee here. So let's see, where were we? So we have this function now where we send in some data, and I also want to send in which one is the select criteria. Yeah, because that's gonna be used further down here. So if we have this one here, and we want to do a keep list, then we go through our new data like this, and online, and we are still having this I number, right? So line I, string value. If the value equals the select criteria, then we will keep that line, So keep list, add line. So what's the problem here? Array type expected found string. Yeah. So get so why did it work up here? Okay, so we did a split up here. Yeah, let's do that then. It's not that important, so let's split it up like that. So if it equals the select criteria, we'll keep it. That's the easy part. So down here, we want a value also if this should be the positive or the negative that we want to keep in this case here. So the least or the most. So let's do another boolean up here. Keep most, like that. So if we are down here, we want if keep most, then the if the, let's see here, yeah, we want another of these ones. So here we want to do this, and we want to do positive here. So here we will keep the most, which were the positive, else so much code, we will keep the least, which were the negative. And okay, so we will have, yeah, we will do this instead. Keep criteria. And here we want it to be select criteria. So if the positive and negative are equal, we will not do anything. We can do like this. If positive is larger, else if it's less, and then we will have a specific case here, which we don't specify, which is the case where they are equal. And then we will use the select criteria. So the keep criteria here, if we want to keep the most, will be one thing, else be something else. So here the keep criteria will be 1, and here the keep criteria will be 0. And if we go down here, in the opposite case, we will just switch these around, 0 and 1. So now we have specified a keep criteria instead, and that's what we want to use in our function down here. So now we only have one for loop, which makes things so much more readable. So what do I do with this get value? Yeah, the get value is let's just keep the two names here. So we have the CO2 scrubber, and we have the oxygen generator. Let's go with that, just to keep it fun. So we will do the oxygen generator number and the CO2 scrubber number. Rubber. Yeah, so let's do that, and then we will have these two numbers that we multiply with each other. So the oxygen generator is a string, which is equal to get value of the new data list. And here we want to have the select criteria 1, and we want to keep the most. And here we want to have a select criteria of 0 and keep the least on the oxygen scrubber. So if we run this, we hopefully will get a good number. We didn't run the right function here, so let's go back and run the right function. And we get the value, if we get a value. As we have a while loop, it can end up in an infinite loop, which would not be good. And the reason we get into an infinite loop is because we haven't changed the new data to our keep list. So that's important to do, of course. So let's try it again and see if we get anything now. There isn't that many numbers, so it should have gone much faster than this. So let's do some debugging. And let's go here and debug it. We have 12 numbers in our new data. We will go into this function. And if it's more than 12, then we will keep it. So here we will go through and count the positive values in the first column, like that. So we go down here. So we have 7 positive and 5 negative. And the keep criteria will become 1 here. And if we want to keep the most, then we want it to be 1 again. And here we go through and see if this is equal, which is not. So we will not keep that. If these are equal, true, so we keep that. Equal, keep that. So when we come down to our keep list, we have 7 left, which was the right number. So let's go up here. Oh, yeah, that's no good. The integer needs to be outside of the loop, of course, or else we will check the same number each time. So 230, I believe that was the right value, seems like it. So let's try it with the real data then. So let's go here and substitute for the real data, run it through. And we get a value of 5,941,884. So let's go over here and put in that value and submit. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. We found the right number on day 3. So let's go back here and reiterate what we did. So first off, we have a function to read our data, and we put it into a list. In this case, we have an array list here. We say that that's called new data. And we have a function here where we'll get the value, where the select criteria, if they are equally numbered, so if we have as equally much positive numbers and equally much negative numbers, what should be the deciding factor? So the select criteria here is a 1 for the oxygen generator, and we will keep the most significant in the bit column. So if the bit column says value 1, then and it has 8 ones and 4 zeros, we will keep the ones because those are the most in that column. And the same goes for CO2 scrubber. What we change the criteria to 0 and keep the least. So if we have the example again, 8 ones and 4 zeros, we will keep the lines where we have a 0 in that column because that's the least amount. And then we will do the same here, switch it over to a number using radix 2 and multiply the number. So let's go to the value here. So in this function, we will first keep track of the column, which is an I. So we could switch this out, refactor, and call it column, which is a little bit more readable. And then we will do a while loop here, and we will count the positive and negative values. So for each line in this column, we will check if it's a 1, we will keep it as positive, else it will be negative. And here we have the keep criteria that we have up here, the select criteria, which in the first case was a 1, in the second case was a 0. So that's a keep criteria if they are equal. If the positive numbers are larger than the negative and we want to keep the most values, then the keep criteria will become a 1, else the keep criteria will become a 0, because then we will want to keep the negative, because those are the least found numbers. And the same goes for if we have the other way around. If we want to keep most, then in this case the negative are the most, so we will have a 0 there, and a 1 in the keep criteria if not. And down here we will create a keep list. What do we want to keep? And then just go through each line, look at the specific column, and then you evaluate against the keep criteria. And if we want to keep it, put it in the keep list, and then we will replace our new data with keep list and increment the column. And we'll do this while we have more than one response value. So hopefully there will be one value coming out here, or there must be at least one. There could be multiple, that would be bad, but hopefully there will only be one, and we will keep that. And as this is a controlled environment, they have probably figured out how to just get one value for each data set. And we got the right result. I hope that you found this interesting. I hope that you learned something today. If you have tried it yourself, you have probably a different solution than I have. So I would really like to see your solution. Leave it down in the comment section down below. If it is a gist on GitHub, if it's a GitHub repository, or if it's just some code, I would love to see it. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.